So in our last video, we talked about process capability and said we want to get to real-time monitor. But to do that, we have to go back through a good measurement system. So this video is going to talk about measurement systems analysis, because what we want to make sure is the measurement system we put in place for process monitoring is actually going to give us true process performance. It's not going to be measuring measurement noise or error in the system. So we will come back and check those particular measures that will be used for the control function of the process. And once we've done that, we will make sure that those measures are then kept in a state of control by having the real-time detection system. So first, what we have to do is choose the measure we need to monitor very carefully. Out of our improve phase and out of our analyze phase, we should see these are the critical performance measures. We understand what we want to do. Do we want to have it maximized, minimized, or set in a level of control? Once we've done that, we need to check the measurement system. How well are we actually measuring? So the rule of thumb is we would like to have less than 10% measurement error no matter what it is. So it's not about the accuracy or the precision, it's about the ability of that measurement system to detect a change that's significant enough to affect a customer. So let's go take a look in Minitab and understand how does that measurement systems analysis work to do this. Now that we're reaching the control phase, we've selected the performance measure that we want to have, and we've understood its capability. What we also have to do is also check to find out, is this process measure working in a state of control relative to our process of measurement? Now remember, we talked about this in the measure phase when we were analyzing the data in the first place. But now what we want to do is make sure that this process is going to stay in a state of control and that the measurement system doesn't drift or change over time. And so what we want to do is go back and do another gauge R&R. And so again, we see this gauge R&R is under stat quality tools, gauge study, and what we want to do is a gauge study crossed. Okay, so the idea is at this time we will only have a cross design. So what we want to do is understand as much as possible what's going on. Now this has an implication, and this is these types of measurement studies are done only when you have an operator interpreting the data and making a judgment call, so that there can be variation from the operator as well as variation from the measurement device that they're using to make a judgment about good or bad. So again, first of all, we probably have done some sort of attribute agreement analysis to find out, is this data actually, the judgment being made properly? We might have done an attribute gauge study, the analytic method, to understand, is the call actually reflecting the measurement? But here what we're going to focus on is the measurement system itself, variation due to the measurement devices and variation due to the people who are calling the process. And so what we see is that we have this data, we clicked here, we're going to use the Anova method, and that will allow us to see is there any interaction between the people and the measurement devices. And so we see that we've labeled these as part, operator, and response or measure data. Okay, and so we can go in now, and here it might be helpful for gauge information to talk about what is the measurement device, what was the date of the study, who was doing it, and maybe when was it last calibrated or the tolerance capability of the gauge. So those might be all helpful things to record because we're in the control phase and we want to make sure the measurement system is checked over time so that its consistency is understood. Under options, we're not going to change any of these types of things. We want to use those as standard, so we keep those as standard. Confidence intervals, we're not going to be selecting, and we're not selecting storage. So we click OK, and here we get the output of the device. And so here we see, here we have 4 distinct categories. Okay, so we said 4 distinct categories is not actually a very good measurement system for a state of control. Now it's okay in terms of doing diagnostic analysis, but in terms of remedial analysis, it's not very good. Because what we see is there is still an awful lot of variation that's coming from repeatability and reproducibility. And so we find in a system like this, we need to improve the performance. But what do we need to improve? Do we have to improve the operators or do we have to improve the parts? So this is the question. So we see variation. There's a lot of part-to-part variation that's happening. And here we see one operator, a second operator, or a little inconsistency, and a lot of inconsistency on the first operator. So as we're looking at this, one of the questions is, what's happening with the operator variation? Why is there so much variation? And we see it's relative to part 10. So now, in the control phase, we want to go back and study, why is there so much of a problem measuring part 10 for the operators? Why are the operators not as consistent across there? So is there a training issue that we have to fix in the procedure? Is there a problem that we have in terms of the fixtures that we use for the measurement? Maybe we're not inserting part 10, or it's being inserted differently because of the geometry of the part. So what is actually going on? So we will not be satisfied here until we can actually get a much more consistent measurement system and we understand how it performs over time. So how do we see if it performs over time better? Again, we'll go back here in terms of stat, quality tools, and we take a look at these gauge studies, and we see that we can have a gauge run chart. So a gauge run chart is plotting the data from the cross study, and we're seeing how does it actually change over time. And so what we're trying to do is, what are the sources of variation in this system as the process is happening over a long period of time? So this would be the chart that we would use on the daily management system to check and say, is the measurement system staying consistent as we continue to use this over the life cycle of our process? So this is very much the same or very similar to taking a look at an individual's chart. But the run chart actually is not as informative because it doesn't have as many tests. So in reality, one of the things we should probably do is what we've recommended for our exploratory data analysis in our measurement system. And that is the idea of the 4-up chart, where we have the individuals chart, the capability analysis, Pareto of defects type, and then the one-way ANOVA, where we see variation for each of the different rational subgroups or steps in the process. And by seeing this, we can understand what is the problem, or where is it coming from? Is it the overall result varying? That would be the eye chart, or the process capability study relative to the spec and say it's not giving us a predictable outcome we seek? Or is it in the one-way ANOVA, where we see there's variation by process step, and that's where we would identify there is a particular measurement problem in one of those steps as a potential source of the variation we're observing. And again, we would come back to the gauge R&R, this one-way ANOVA, to understand what's actually happening at that particular step for that particular measurement. So this is a reminder. This gauge R&R, yes, it's important to do at the end, but it's also important to make sure that we maintain control of the measurement system so unwanted variation due to measurement error doesn't creep into our daily management of the process. Now that we've got a good measurement system, we're ready to get to the final stage, and so let's put into effect a process to monitor, control, and alert us to the fact when these measurement systems are doing something unusual and help us to anticipate, do we have to have some sort of corrective action to keep the performance operating within the bounds of the measurement we set for the tolerance of good results? So let's come back and then we'll take a look at the third of these Minitab videos where we're going to talk about individual control charts.